Welcome back to our live training session here with our Honda EP3 Civic. This training module, we're going to be focusing on dialing in our part throttle or cruise area of operation. This is going to be for both fuel, spark timing, and variable cam control. Now we're really going to be focusing, if we turn our attention here into the laptop screen, from everything from 40% throttle to about 1% throttle in here. This is going to be the range that we're going to be focusing on dialing in. Now, part throttle cruise, I'm not going to go much higher than about 6,500 within the table, so we're really kind of narrowed down to this area right here. So we want to go in and dial our fueling in. That's going to have the biggest impact for the drivability and overall engine operation. We have a reasonable spark timing table developed. We'll talk about that here in just a minute, but we're going to be focusing on dialing in our fueling first. So we always want to dial fuel, then we want to dial our spark timing in. Now, how do we dial our fuel in? We have a couple different options here. I'm going to be showing you both in the training module. First option is going to be simply driving the vehicle and watching what the closed loop correction is showing and doing in terms of the trim. If we take a look here at the O2 correction, this would be our short-term fuel trim equivalent to a factory ECU. So what this is doing is taking a look at the actual wideband reading, comparing it to the desired target. Now we've set our desired target table. If we go here to our O2 closed loop target table, this is going to be where we want to run our engine at various different throttle angles, in this case alpha N for load, and engine speeds. We can see here that in the normal cruising area here from, let's say, 5,000 and below, we'll be shooting for roughly 14.5 air fuel. Even here, 30% throttle, we're about 13.9, 14 to 1 air fuel. So we want to shoot for a leaner air fuel mixture so we have reasonable economy and the engine doesn't need to run as rich right there. So we definitely don't want to go ahead and waste fuel and foul out spark plugs. So we're going to be focusing on operating in a pretty lean, or leaner, I should say, not super lean, but leaner burn out of our engine. So we've established the mixture here. Our goal is to now dial in our main fuel table here, so the values within the table, to be able to hit that desired target that we're requesting in the table. The closed loop correction is going to be taking a look at the actual lambda reading or actual air fuel reading from our wideband sensor, comparing it to the target, and it's going to make a trimming percent. Now, one method in order to calibrate and tune our table is we can simply drive and watch what the O2 correction is doing here. Then, if we're seeing that, let's say it's taking out 10% fuel in a certain area, we can highlight the area, click M for multiply. If it's taking away 10%, we would type in something like 0.9. If it's taking away 20%, we would type in 0.8. And we can see what that mathematical equivalent is here right to the right. So it's going to show us what adjustments we need to make. If it's adding 20%, we would type in here 1.2. We see that's going to be adding 20% to the table. So we're going to be, or could be, watching our O2 correction and making adjustments on the fly based on what it's showing. That's probably the quickest way to do it if you're on a chassis dyno. But if you're not on a chassis dyno and you have to drive your vehicle in order to populate this, so this would be real world conditions, we can utilize an O2 overlay feature in our logging and allow the correction to actually take a look at what the O2 correction is doing, allow that correction factor to be applied right back into the table and have more of a auto-tune, hands-off type of approach. This might be the other option that you want to dial in and work with your fuel table. I'm going to first demonstrate, once we get the engine fired up and running, working with the just basic option where we do a little bit of driving here, and then I just go and watch what the correction is doing, and I'll just model that here, and we'll use the multiply function again, hitting the M key and adding or subtracting the fueling to get close to the target and have the correction here making minimal adjustments. If we get our correction within plus or minus 2-3%, everything's dialed in, we're good to go. Anything outside of that, I'd like to go clean that up and make sure my main fuel table here is dialed in as best as possible. So we're going to be approaching our table going 40% throttle and below, and again, 5,000 RPM, this range, even probably about 6,000 RPM. We're going to be focusing right here. The rest of the table, we can extrapolate looking at the values here. Let's say we figure out at 6,500, we can bring those up to the higher RPM here and then figure out what these values are going to be. Ideally, you'd like to drive it there, but that's not going to be where we primarily drive our vehicle. It's not going to be hanging out here in the super high engine speeds. Now, we will be taking a look at full throttle tuning in the next tuning tutorial. That's going to be dealing with our 60 to about 100% throttle range. We'll calibrate that and get that all set up, and that's going to be a completely different process, but similar idea. So we need to dial the fuel table in. We'll either use the O2 correction and the multiply function, or use the correction through the logging, as we're going to demonstrate here. So we're going to look at both options. That's fairly simple. Now, once the fueling is dialed in, we're going to be taking a look at our ignition timing and then learning how we can optimize our spark timing by utilizing a live torque output on a chassis dyno. Now, the values that we have in here are reasonable and safe starting values. So if we're looking here, 40% throttle and below, we have our values anywhere between, let's say, 20 to 30 degrees of timing. We're likely to have more ignition timing, or be able to run more ignition timing. However, we want to start off with something that's maybe 75 or 80% of the way to what's known as maximum brake torque. Maximum brake torque is where we run our timing up to a point where it's going to give us the best torque output. And anything beyond that spark timing we're trying to command from our timing here, timing table, it's not going to give us any further torque production out of our engine. Now, we may be octane limited, there may be other factors that we can't run that much spark timing, but we always want to try to reach maximum brake torque. It's going to get the peak efficiency out of the engine, and what's going to happen is you'll use less throttle angle to maintain a certain vehicle speed or operation condition, and that in turn is going to use less fuel, so it'll make the engine more efficient and also have more throttle response available. So we definitely want to try to optimize things, and we'll be using the mainline dyno. I'm going to demonstrate how to do that process. It's fairly simple, but that's one of the last things we're going to take a look at. Now, one thing that we have to take a look at right now and immediately before we even touch or go after our fuel table and do any actual tuning in there, we have to set our variable cam control table up, and we also have to set the variable cam control so it's functional here on our Honda K-Series engine. Now, we only have variable cam on our intake cam, but it does have a strong influence on the airflow ingestion for the engine. So if we get our variable cam timing right, that's going to give us a broader power band, have better cylinder filling for our engine, and overall make a better power band and have more throttle response and more engine torque at less throttle angle. So it's going to do all these things that are going to improve the engine's efficiency, and we definitely want to take advantage of the variable cam. A lot of people delete it. I recommend that you don't delete it and you keep it on the engine unless the cam profile that you're working with doesn't support the actual variable cam function. Some race cams, some drag race cams for the K-Series are going to be locked VTEC and no variable cam or VTC movement. That's fine, that's a different story. But if you're tuning a relatively mild K-Series with drop-in cams, you definitely want to take advantage of that variable cam timing. So how do we do this? Let's first set up our variable cam target table, then we'll fire up the engine and we'll do some tests to figure out setting up the actual variable cam control position so it knows how to track the sensor correctly. And then we can go in and look at the actual operation and verify that it's actually tracking the target properly. We might have to adjust our proportional, integral, and derivative gains so that the closed loop behavior for the variable cam control is doing exactly what we program. We want it to track to the target pretty precisely. We don't want it varying off the target. So by working with the variable cam timing, this allows us to control the overlap on the cam dynamically. This would be the same idea if you have, let's say, an older engine that's non-variable cam, you have adjustable cam gears, and you're moving the cam gears and you're trying to gain power or torque in certain RPM ranges. You know you're able to gain some power, let's say, by going in, taking out overlap or adding overlap in certain areas of the power band, but you'll lose in other parts of the power band. So the variable cam allows us to take advantage of essentially a dynamic cam gear movement on the fly, and it definitely will improve efficiency, engine torque output, throttle response. So we absolutely want to take advantage of it. Let's take a look at that right now. That's going to require us to move down here under our other functions option, and we can see we have variable camshaft VVT selected here. We can see that's turned on. We've assigned it to the output, and we're going to assume it's going to work. We'll figure that out here in the tutorial. A couple things with this, we take a look intake cam. Intake 1.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.